Good morning. In this Coffee and Cleaners, I'd like to discuss the prodigal genius that was Ira Spencer. Ira Hobart Spencer lived a relatively short life of 55 years, but in that time took out over 100 patents. I have here a selection of fewer than half of those patents, just the ones that relate to vacuum cleaning, that I'd like to run through. I have them organized by the application date that kind of show the evolution of the designs that he introduced. Ira Spencer, at 19 years old, formed the Organ Power Company to manufacture organ blowers, initially water powered, but then shortly thereafter powered by electricity. As a teenager, Spencer devised the organ blower to save him of the laborious, mind-numbing, boring task of pumping the organ at his church where he worked. And he organized this company. He sold organ blowers to such an extent that most of the pipe organs in this country were powered by Spencer turbine blowers. And in 1905, he invented the turbine vacuum cleaner. In 1907, organizing the Spencer Turbine Cleaner Company, which later, I think around 1918, merged with the Organ Power Company. And so Ira Spencer, who lived from 1873 to 1928, forever influenced the world of vacuum cleaning and air moving. And here in 1906, we see a multi-stage horizontal turbine with an adjustable motor base. Here's a multi-stage downflow turbine, once again with an adjustable base. We see a separator before the impellers in this case. Here's an early hose swivel. That hose swivel has always been a distinctive feature of Spencer systems. It saves the hose from wearing out right where it connects to the wand. Here's an early separator. This is a telescoping inlet pipe and a weighted cloth bag, and you could remove this for cleaning or replacement through the door here. Here we see a wet cleaning central vacuum system, and you can see this is turbine driven, of course, but the patent relates to the tool, which has an air valve, a water valve, a soap dispenser, and a brush and pickup squeegee. This is 1907. Here's a patent for a swivel joint connection for the tool. Here is the next few patents have to do with this turbine design. They're all pretty similar. And at this point in the design, you had the intake, which would just have a gravity drop for larger debris down into the collection drawer here, and you'd move through a lot of the dust would move through the turbines, through the impellers, drop down into this tray, and then finally the air would go up into a filter bag before the exhaust. You can see same idea here. This is a little different. Even though I am a patent attorney's son, I'm not well versed enough in patentese to know what the big differences in these patents are, because to me they look like they're for the same machine. This one we have the first use of a tubular bag separator with multiple smaller bag filters, and that is still in use today, not only by Spencer but by basically every car wash vacuum manufacturer uses that tubular bag design. And this we still see intake, separation there, we have a screen after the impellers, and then we have the final filtration at the exhaust. This filter bag had a weight sewn in it so that not only could you remove it easily, but also if it became loaded up with dust and clogged, rather than it just ripping, which could happen at the time, it was a problem that he faced. This bag would just rise up, and I guess you would let all the dust in the exhaust tell you that the filter bag needed attention. Here we have a patent for a more refined wet cleaning wand that incorporated a valve handle that you would turn to turn on or off the suction, and then a little button that you would push for water. And so you could spray the floor down, you could scrub it with this, and then you could flip the whole tool over and squeegee the floor dry, and the vacuum would suck the solution away. We're still in 1907 here. This is an early inlet valve design. You can see how far from the wall this stuck out. This was very typical of the day. A lot of them were screw threaded. This one was just a friction coupling, and it incorporated an on-off valve in addition to just the hinged flap itself. Here's a tool designed to clean linoleum floors where the mouth of the tool was down flush with the brushes. And this is a 1908 patent. We have a combination dusting brush and tuft cleaner nozzle. So you could use the dusting brush, or you could loosen that wing nut, slide the brush up on this tool body, and expose the nozzle inside. Here's a cool one. So in a large vacuum system, he makes reference to one installed for cleaning rail cars with hundreds of feet of piping. If the system was lightly loaded, so if not very many operators were on a lateral, you would not have enough airflow going through the lateral in order to keep it clean. You'd have this buildup of dirt laying in the bottom of the lateral. And the way to solve that is to go down to the end and open the pipe up and let the air kind of flush out all that stuff. Well, we're talking hundreds of feet long, each one of these laterals. So he devised a way to remotely activate a flush out valve from the location of the separator. So alongside each one of the main cleaner lines, you would have a small pipe that would lead to this diaphragm valve, and you would have this manifold. So let's say you want to clean this lateral here. You open up this valve. It opens up this at the end of the line and lets the air come through and clean that line out. Just fascinating. We've got, we're doing the horizontal turbine design with gravity separators before and after, and then the bag filter. Here we see a vertical turbine, and we're first seeing the guard screen in a tangential intake. So you'd have a little bit of a cyclone in here. You'd have most of the dirt dropping into these pans, which you could pull out to empty them. And then the air would go through the screen, down through all these impellers, and then it would hit this cup, and the air would be forced out the exhaust, and you could empty and clean out the bottom of the thing here through this pan. Here's another application for a hose swivel. And this knurled handle is also a shutoff valve, so you could turn the airflow on and off. It was common practice at the time to just leave the turbine running, but to turn off the airflow, which would save energy when you weren't actively pushing the thing around. So instead of going and shutting the thing down, you would just turn the airflow off and the turbine would run at idle. Here's a more refined inlet valve patent. This is beginning to look like a typical Spencer inlet valve. You can see it's flush with the wall. There's no more shut off. You can see we have the hose lock. This little piece here is what engages with the end of the hose and prevents it pulling out of the wall. And there would be versions for recessed or surface mounted installation. Here we have a wet pickup separator, patent from 1908. And this would be for wet cleaning. It has a deep seal trap. This is just like a P-trap under a sink. The reason it's so big is to prevent the suction from drawing the water out of it. And we have a flushing connection, so when you emptied this, you would turn the water on and it would flush out the contents. And we have a flip over rug and floor tool, similar to what GE would come up with in the 50s, and Electrolux also would come up with their version in the 50s. Ira Spencer had that in 1908. I find it odd that this tool didn't seem to catch on though, because this to me seems like a brilliant, simple design. In 1908, we're seeing, this is more like the early Spencers that you see kind of still out in the wild, with that initial separator on the top. We have another separation stage at the bottom here, and finally a bag filter on the exhaust. Here's another 1908 patent. This is for a vacuum-powered chalkboard erasing system that you would install in schools. So we had, in 1908, this was what his little representative drawing of a turbine. And you'd get a pipe to a cavity below the chalkboard in each classroom, and you'd have a small hose that would extend to the chalkboard eraser, and when you lifted the eraser off of its little home there, that would open a valve, and you'd have suction pulling the chalk dust away as you erased the chalkboard. Here's a design for a rubber-bodied floor tool that would be flexible to get around table legs and things. So the middle part was metal and the wings were rubber, so that you could flex them around obstacles as you were cleaning. I'm sure it wore out pretty quickly. 1909, here's a fiber-sided floor brush. Not a brush, a tool. Swivel connections for the wand. You can see the elbow is part of the tool in this case. And in 1909, we first see the Spencer hose swivel. Not the hose swivel, hose connection, which is the all-rubber clincher coupling connection, as they called it. And it was airtight, easily put together and taken apart, no screw threads or anything like that. And at this time, the male end and the female end were both rubber, so you didn't have any metal parts that could damage the floor. This is still in use today, but at least going back to the 1930s, the male end has been metal, and only the female end that you'd connect the wand to would be rubber. So this, the ends of the hose fit together, so you could either plug this end into the wall, or you could plug it into another length of hose and extend it. Here we've got a locking valve to prevent curious youngsters in schools or public buildings from opening the vacuum inlets and causing trouble. So this eccentric would be key operated from the face of the valve, and it would lock into the body to prevent opening it. And this also shows a reversible escutcheon, so you could either have the valve sticking out here, more I don't know what's the word, but you could take the same escutcheon and flip it around, and then it would be a recessed valve. Here we see a more refined tool design. This is, I mean, you can still get Spencer wands and tools that look exactly like this. And this has the elbow as part of the wand, which make the tools simpler to build. And it also has a thinner metal stamped or pressed steel design for the tool body, and then a thicker cast metal replaceable shoe on the tool. So you had the benefit of a harder wearing surface that would contact the floor, but a lighter and cheaper tool body construction. Here's a design for a crevice tool that shows these slots or these holes being graduated, so they go from a smaller size to a larger size to help even out the airflow over the face of the tool. Here's a design from 1910 for a bearing which resists dust getting in it and also resists oil getting sucked out of it by the suction of the turbine. And here's a 1910 design for the side arm separator, which shows the latch detail and shows how this top of the separator is one casting with the top of the turbine. And this is very much like my machine, my earliest Spencer machine, which I believe is from 1911. And we also see we don't have any separation occurring after the turbines at this point. It's all just a small cyclone before and a guard screen, and then anything that goes through here just goes straight out the exhaust. This is a design for self-cleaning or non-loading deflectors between the impellers. You can see how deeply he's tapered these deflectors to prevent dust and dirt from accumulating in here. They would just sort of, the dust would find its way down through the stages and then get blown out instead of needing to take them apart and clean them, as I'm sure would happen on the early systems. This patent has to do with this valve on the exhaust, which prevents overloading the turbine. So if too much air is introduced into the system, the motor can be overloaded. And to prevent that, if you get too much air passing through the exhaust, it flips that little door up and limits the airflow, which also in turn limits the current that the motor can draw. And this would be an adjustable valve. You can see they set the minimum and the maximum with these adjustment screws. I imagine this valve would get sort of clogged up pretty quickly though. We've got a tool design swivel joint. This is quite similar to that other patent we just saw, but this again, like the Spencer hose connection, the wand, the locking chuck, and then the same tool connection at the bottom. This is in 1911, and you can still get this, pretty much this exact setup today from Spencer. Oh, this is neat. This is a wet-dry separator with flushing connections to the water line on the intake and the exhaust. And this water line would be automatically activated when the suction started from turning on the turbine. That negative air pressure would pull up this valve and start the water flowing, which would mist the exhaust down, and that liquid would drain out the sewer, and then the air exhaust would go up the sewer vent pipe. And these flushing connections enabled you to clean out the separator over here and then discharge into the same sewer. Here we have a high efficiency cyclone, so instead of just the small short-bodied cyclone, we have a taller version to separate the fine dust out a little bit better. Oh, Ira Spencer invented the Baird airflow meter. How do you like that? In 1912, he came up with this spring gauge tool that you would hook the hose to and select the orifice size that you wanted to measure, and then that spring gauge would be calibrated to indicate the amount of vacuum, which would also tell you the amount of air that was being moved, because at a given orifice size with a given amount of vacuum, you have a definite amount of airflow. And, you know, for example, at 5/8 inch orifice, which was the carpet tool, if you had 4 inches of mercury, that meant you were moving 46 CFM. And that little table was incorporated on the body of the tool. Here in 1912, we see the first appearance of the sugar scoop housing design, which characterizes Spencer blowers to this day. And this says casing for organ blowers, but your organ blowers, your turbo compressors, and your vacuum producers, which were 3 names for the same kind of gizmo, but depending on what job they were doing. To this day, this is a Spencer trademark, that cutaway design. Here's a patent for self-balancing impellers that were designed to be flexible to resist vibration. And this patent text goes into the difficulty of balancing these, because even if they run balanced at one speed, they can be unbalanced at another. Or even if they're running balanced outside the casing, once you assemble them together inside the casing, then they can be unbalanced, and it's just a pain to get them all to run balanced. So this design lets the impellers flex a little bit and balance themselves, basically. Here in 1913, we see the design for the vacuometer, which is this globe-shaped measuring device that you would hook to the end of the hose. You'd have a needle-type vacuum gauge here, and this would read in inches of mercury, of course, as was the standard at the time, and remains the standard to this day in industrial vacuuming. And you could select the orifice size that you wanted to measure to simulate a carpet tool or a floor tool, and the Spencer standards would guarantee that the system that they specified would produce a minimum amount of vacuum at the end of a vacuometer attached to however many hoses the system was rated to operate. Sadly, the vacuometer is no longer in production, and hell if I'll ever find one. Here's another type of hose end measuring device. You'd hook the hose up here. We have an orifice plate down here. And this is a U-tube full of mercury that is attached to a rubber pivoting mount. And the idea is that the ends of this tube are closed off normally so the mercury doesn't spill out. And then when you want to take a measurement, your thumb would just flex this rubber bit down, opening up the ends of the tube and allowing you to take a vacuum reading. Here we've got a machine based off of a turbine vacuum, but it is for rubber, producing sheet rubber. And you would suction the premixed rubber compound out of here, and it would go through a separator and get discharged down. And one of the big ideas of this patent is that this valve makes sure that you turn the airflow off before you can open the hopper. Here's a patent for the butterfly valve, very common in industry today, but this was Spencer's invention, 1918. Here's another 1918 patent for a self-resetting butterfly valve. This was designed to be on the exhaust of a turbine. This would be more for industrial processes like air moving, for whatever, for all kinds of purposes. But you were supposed to start the turbine with the valve closed so that you didn't overload the motor, and then you would open this valve to whatever amount of airflow you needed. And this patent is a self-closing valve, so that when you turn the turbine back off, this little airline here would relieve the pressure on this diaphragm and would turn this valve back closed again. There was a spring here so that you could then restart the turbine without having to remember to go back and shut this valve. And here we've got a later patent in 1925 for the more common version of the silent hospital valve. So you would plug the hose in part way, and then you would open this flap up and plug the hose in all the way, do your vacuuming, and then when you withdrew the hose, this spring-loaded flap internally would close, and you could take the hose out without having that loud rush of air. So this was commonly installed in hospitals, and in fact Mercy Hospital in Chicago has these in their lobby. Here's a turbine power brush patent from 1925, and it includes a little teeny impeller with a worm drive to a slow speed brush, and this design incorporates a tray on top to catch the larger debris so that only the finer dust would actually make its way through the moving parts. interesting design. And finally, the last patent that I could find for vacuum cleaning from Ira was from 1926, and this is for a combination felt bladed and sheepskin tool for cleaning polished floors. And even in the 1950s, this was sold as the rink tool for roller skating rinks. So once again, this is less than half of Ira Spencer's patents, and I think that rightfully earns him the name of the Nikola Tesla of air moving and vacuum cleaning. 55 years old, and his inventions are still for sale and in use to this day from the Spencer Turbine Company of Windsor, Connecticut, formerly of Hartford.